This is 9-1's homework assignment in the textbook, looking at quadratic functions and parabolas. And we're going to jump right in here on number 1. So we're given the function g of x equals 1/2 x squared. And they're going to ask us to do 3 different things. Letter A, make a table of x and y for integer values. Remember, integers are whole numbers, positive, negative, and 0, from -4 to 4. So we're going to make an xy chart. And we're going from -4, using our integers, so whole numbers, -4 to 4. So if you don't have a graphing calculator, you have to do this one by one, and you're just plugging the numbers in, and we can do that ourselves. It's actually not that difficult. So we'll run through this once, doing it by hand, and then I'll show you how to do it in the graphing calculator. That might make your life a little bit easier if you've got one. So I'm plugging in for x, and I'm finding out what y is, because remember, y is the same as the function g of x. So if I plug in -4, I'm going to square it and then take half. Okay, multiplying by a half just takes half. Remember, when you square a number, whether it's positive or negative, it's going to end up positive, because a negative and a negative is a positive, and a positive and a positive is also a positive, obviously. So when I square -4, -4 times -4, 16, take half, and it's 8. -3 squared is 9. Take half. Now, you can do that in the calculator, or you could just leave it as a fraction if you wanted to. 9 divided by 2, which, if you go ahead and do that in your calculator, is 4.5. So whichever way you want to do that. Plug in -2 squared is 4. Half of that is, oops, I almost wrote 4, 2. -1 squared, -1 times -1, that's 1. Take half of that. Half of 1 is 0.5, or 1/2. Plug 0 in. 0 squared is 0. Half of 0, you're just multiplying. Anything times 0 is 0. Plug in 1. 1 squared is 1, and half of that is 0.5, or half. Plug in 2. 2 squared is 4, and half of 4 is 2. And you start to see that as we move away from 0, we're going to have a mirror image on both sides. And the reason is, whether we plug in -3 or +3, once we square it, we end up with the same number. So then in the end, we're going to get the same answer. So when I plug in +3, 3 squared is 9, and half of 9 is 9/2, which is 4.5. And then number 4, plug it in. You're going to get 16 when you square it. Take half, and that's 8. And we'll come back and look at that in the graphing calculator in a second. Part B, they want us to graph this, so we're just going to do a quick, simple graph. Our x values should go from -4, -3, -2, -1, 1, 2, 3, 4. And we got to get all the way up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. You can go ahead and use the lines on your paper to help you if you kind of just go halfway for each one. Gives you a nice equal distance. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm just going to go ahead and use my chart. So at -4 for x, I have 8 for the function. For -3, I have 4.5. So 1, 2, 3, 4.5. For -2, I'm at 2. So right there. -1, I'm at a half. So here's 1/2 is going to be underneath that. And then 0, 0. 1, I'm at a half. 2, I'm at 2. 3, I'm up at 4.5. And then 4, I'm back up at 8. And this does go on forever in both directions, so I'm going to put an arrow on those. And then letter C, once you've put the graph there, you can clearly see this is going to open up. And the way we can find that out before we even do all of this is to look at the coefficient of x squared. If it's positive, it's going to open up like this. If this was a negative 1/2, it would open up down. So let's take a look at this quick on a graphing calculator. If you downloaded the graphing calculator that I recommended on the computer, it's going to look like this. So we're going to go ahead like we normally do and go to y equals. And we're going to go ahead and put in our function. Now, on the calculators we have at school, there was a shortcut, alpha x, would bring up a fraction. It doesn't work on this one. So we actually have to go to the fraction function. So you're going to click on math, and we got to get over here to fraction. And it doesn't let me click on it. So just like you would on a regular calculator, you're going to have to scroll over to it. And when I get to fraction, this first one is what I want. So I'm going to either hit enter or hit 1 because it's choice 1. And you can see it brings up the fraction that we're used to. So I'm going to put in 1/2. Scroll off of it. Here's my x. Still the same button. And to square it, we've got the x squared button, or you can raise it to the second power, either way. So I have 1/2 x squared. That's exactly what I want. And if I was going to go to the table now, I've got all the numbers that I need. I could scroll up if I want to -4. And there's my 8, 4.5, 2, 1/2, 0, and scroll down, and boom, I've got all of that. And if I wanted to look at the graph, just click on graph, and I can see that it opens up right there. Okay, so the graphing calculator can help you make that table quickly. Otherwise, you're just going to go through piece by piece. All right, so moving on here to number 3. We're referring to this graph on the right. Does it open up or down? Okay, that's clearly down. The parabola is the graph of a function. Which does this function have? A maximum value or minimum value? And so we are looking for the vertex, which is the kind of that middle point where everything mirrors on both sides. And it's either always going to be the top or it's going to be the bottom. And since this is the top, that is the highest value that we have. Everything else is going to be less than it. That makes that a maximum. Letter C, give the coordinates of the vertex. So that's that point right there. The coordinates is 0, 0. And letter D, we're going to write the equation of the axis of symmetry. So the axis of symmetry is the line that basically cuts this thing in half, where it's the same on both sides. It's symmetrical. If you folded your paper on that line, the parabola would fold on top of itself. And so it's the line that actually goes straight down the y-axis. So how do we write the equation of that line? Think about a line out here. If it went straight up and down, it would be x equals 3 or x equals 4. That's the equation of the line, because anywhere you go on that line, the x value stays the same. So the y-axis, the line that sits there, the x value is always 0. It's not positive, it's not negative, it's 0. So the equation of that line, the equation of the axis of symmetry, is x equals 0. So our next question is going to be number 5. We're going to go ahead and we're going to match these up. So really you can just look at these graphs and find all the points. If you notice with the A, the B, and the C, they all have 0, 0 in them, and you can see all of these graphs have 0, 0. So we're really looking at everything else. If you look at letter A, both at -2 and +2, the y value is 4. So here at +2 and -2, the y value is negative. Same thing here. And over here, we have positive values, and at -2, we're at 4. At +2, we're also at 4. Okay, so that's going to have to be letter A. So A is the triple I. Letter B, -2, -4, +2, -4. So that matches letter I, and we'll double check this one. At -2, we're down at -10. At +2, we're also down at -10. So letter C matches right here. Okay, number 6, we're matching these to the graphs here. So same exact idea, except instead of a table, we're given the equation. And instead of separate graphs, they're all on the same graph, but relatively the same idea here. So y equals x squared, if I look at that compared to the other two, these are both going to have these negative coefficients, which makes this open down. So since this is a positive coefficient, I notice it has to open up. And so for letter A, there's only one choice. It's got to be this triple I. Now when I look at these two, clearly one is skinny and one is fat, and sometimes this can get confusing because at first, if you're just thinking off the top of your head, you might say, well, -3 sounds like a bigger number than -0.25. And so because of that, it's going to make it fatter, just because that seems to make sense. It's not actually true. So what we're going to do is we're going to just plug in a random number here for x and just think about what our answers would be. So let's say we plugged in 2. So if we went to 2, and again, this isn't marked, so we don't know where it is, but if we went to 2 on the x-axis, these are going to have different values. So if I plugged in 2, I'm going to start here because there's no decimal. 2 squared is 4. 4 times -3 would be -12. So at 2, y would be -12. So 2, -12. Well, we can't really tell what these marks are. So what would it look like on the other one? If I plug in 2, 2 squared is 4. 4 times a fraction, whether it's negative or positive, is going to make it smaller. So this is going to be a number smaller than 4. It's actually going to be 1, or -1. So this is going to be down at -12, and this is going to be at -1. So at 2, this one, the -3x squared, is going to be all the way down at -12, while the other one is just at -1. So that shows you that this dotted line, or I, is actually going to go with letter C. And then this one is going to go there. Now again, if you have a graphing calculator, you can go to your y equals. Let's clear this out. And put these in. So -0.25 x squared. Let me do that. So going down, -3x squared. Now, if you got to be careful and look, make sure you see which color is which. The -0.25 is going to be my blue graph, and -3 is going to be my red. So if I go to the graph, it's going to look like that. And so you can see my blue graph is the 0.25, and my red graph, if I go back to y equals, my red graph is the -3x. They kind of show you everything right here, but it does lag a little bit. So you want to see it, click on the graph, make sure you're getting the live version. And so that also is just a quick way to double check these. All right, we are going to number 7. So we're just filling in the blank here. Consider the graph of the function. This is the basic equation of the functions we're looking at, ax squared. If a, the number, the coefficient, is positive, that graph will always open up. In letter B, if a, the coefficient, is negative, it is going to open down. Next up, number 11. Parabola at the right has the equation y equals -5x squared. Find y if x equals 0. So if you plugged in 0 for x, you could find it out here. But if you just plugged in 0 and start raising it to a power and multiplying, it's still just going to be 0. So letter A is just 0. Letter B, you got to be careful what they're asking for. Now they want you to find x. What's x if y is -5? So if you were going to solve this as an equation, you'd plug in -5 for y, and you'd have to work backwards and solve it, which you could do. They kind of want you to do this with the graph. That's why they gave it to you. So when y is -5, which would be here in between 0 and -10, what is the x value? So there's two answers. It's here and here. And they're picking those out specifically on the lines. Now, it is always hard to tell. Is it exactly in the middle? Is it at 5 or what does it be? -6 or -7? But this question, they are simply asking you to find those two values there. So x equals -1 and 1. Letter C, find x if y equals -20. So when y equals -20, my x values are sitting right on those lines. X equals -2 and x equals +2. Okay, number 12. Squeeze it in over here. We're referring to this parabola on the right. Points P and Q are reflection images over the y-axis. Okay, so mirror images over here. So here I went left 3, up 20. So to get to this one, if it's the mirror image, I'm going over 3 to the right and up 20. So what is the coordinates of Q since it's the mirror image over the axis? So I'm still going up 20, so that part's not going to change. But instead of going left 3, I'm going to the right 3, which makes it a positive 320. (13) Considering the expression -1x squared. Letter A, if x is a negative number, what do we know about our answer? So any negative number squared is going to make a positive. So I'm going to have a positive times -1. So I know my answer is going to be negative. So if I plug in a negative number, I get a negative answer. Letter B, if I plug in 0, 0 squared times this is going to be 0. If I plug in a positive number squared will still be positive, times -1 will also produce a negative answer. And so letter D, based on what we just looked at here, what do we know about this function just looking at this? So we know that whether we're going to have a positive x value or a negative x value, I'm going to have a negative answer. And I know when I have 0 in, it's going to hit 0. So if you thought about this on a graph just in your head, I know that when I plug 0 in, I get 0. So I'm going to have a point 0, 0. When I plug in positive numbers, I'm down in the negatives. When I plug in negative numbers, I'm still down in the negatives. So my parabola is going to look something like this. And so we could say that the function is a parabola with a vertex of 0, 0. It's an important vocabulary word. And we know because of this -1, because of our answers from A and B, that this parabola opens down. All right. 14 will be similar. So 14, we're looking at the expression 4x squared. So if we plug in a negative squared becomes a positive, a negative times another positive, so I'm still going to have a positive here. Letter B, if I plug in 0, 0 squared is 0, times 4 is still 0. If I plug in a positive squared is still positive, times another positive, we're going to have a positive answer. And so similarly to what we did on the last question, what does A through C tell you? This is a parabola with a vertex of 0, 0 that opens up. 15, what's the only real number whose square, when you square it, is not a positive number? So real numbers include fractions, decimals, not just integers. Integers are your whole numbers. So real numbers can be positives, negatives. It includes fractions and decimals. What is the only real number? When you square it, you don't get a positive number. Any negative when you square it, even if it's a fraction or a decimal, will be positive. Any positive you square, it's going to be positive. So the only number when you square it that you don't get a positive number is 0. Okay, 19 and 20 are our last two questions. So we're looking at this equation for an object falling. 16 times t squared, distance equals 16 times t squared. So letter A. An object falls 400 feet in t seconds. So we don't know what t is. We're trying to find t, so don't plug in for t. We don't know what it is. We know that it fell 400 feet. That's the distance. So the distance it falls is equal to 16 times however many seconds squared. So we are plugging in for what we've got, which is d. So 400 equals 16t squared. We need to solve this equation. And to solve it, we want to get t by itself. So we're going to divide by 16. So 400 divided by 16, we get 25. So 25 equals, this cancels, t squared. So not t squared is 25. So if I want just t, I take the square root of both sides like we've been practicing. And the square root of 25 is a nice number. It's 5. So if you were going to write this out, remember this is 5 seconds, but t equals 5 is a good answer. Part B. Estimate how long it would take an object to fall 200 feet. So 200 again is the distance. It says estimate, which means we're probably not going to get a perfect answer. When we square root, we hardly ever get a perfect answer. So we'll just kind of round it off. Let's see what happens. First thing we need to do, though, is isolate t squared, and then we'll take the square root of it. So we're going to do 200 divided by 16. We get 12.5. And again, that's t squared. We need t, so we're going to take the square root. So the square root of 12.5. Now it says estimate. So we're rounding this off. You can round it however you want. If this was like 3.9, then I would say about 4 seconds. If it was 3.1, I'd say about 3 seconds. But since it's right in the middle, I'm not going to round it up or down. I'm just going to leave it as 3.5 seconds. So I'm going to say t is approximately 3.5. Last one. Some quick review, some skills that we want to keep sharp here as we move forward. You're going to see that we're still using our square roots, so we got to remember these properties. So square root of 3, this is part A, times the square root of 27. You may look at the square root of 27 and realize that you can simplify it, and you could early, and some things would happen. But for the sake of this one, it's actually easier if you just go ahead and multiply. You can multiply these together. You're just going to end up with the square root of whatever this is when you multiply. So 27 times 3 is 81. So when I multiply these together, I get the square root of 81, which we should know. The square root of 81, what number times itself is 81. 9 times 9 is 81. So the square root of 81 is just 9. Part B is similar. If you look, we've just added an x in there. So the square root of 3x times the square root of 27x. Again, we can just multiply these together, so the coefficients get multiplied, so that's still 81. X times x is x squared. Remember, you add your exponents. When you're multiplying, it's x to the first times x to the first, so you're adding 1 and 1 to get 2. Now we're taking the square root of this. What times itself is going to give us this? So we know the square root of 81 is 9. And we should know the square root of x, the square root of x squared is x, because we do that all the time, right? We take the square root of the variable squared to get it by itself. So if we took 9x times 9x, what would we get? we would get 81x squared. And so because it's something times itself, that means it's equal to the square root of this. So the square root of 81x squared is 9x. Okay, part C. Now, I thought about not including part C, but I think it's a good exercise to go through, and will kind of open up your eyes a little bit to how this could work. So I didn't necessarily expect you to get this on the first try. I was hoping that you'd go back and watch the homework video and that this will make sense, especially as you get towards Algebra 2 and later on when you work with this kind of stuff more often. Your skills on how do you break these apart and how do you simplify, those things are going to matter. So we're going to practice this, and this will help you out in the future. So square root of 3x plus, so okay, it's different, it's plus 27x, square root of 27x. So you can multiply these together, but you can't just add them together. If you think about, we've simplified these down to things like 4 radical 17 or something like that. If I added 4 radical 17 and 4 radical 17, I would get 8 radical 17. So what's actually happening is these are kind of like a variable. If I had 4x plus 5x, I get 9x. The variable doesn't change. It doesn't become x squared. That's only when I multiply. So the same thing is happening here. I can't add these together. If I have 3 radical 2 and 4 radical 3, these stay separate. I can't do anything with it. But if I had 3 radical 2 plus 4 radical 2, those I could put together. The coefficients would go together. This is 7 radical 2, adding them together. Notice that the radical doesn't change. So it's 3 of these, it's 4 of these, so I have 7 of those. I can put it together. But if I have different square roots in here, different radicals, I can't put them together. So right now, just looking at this, going back now, I can't put these together, okay, because they're different. So what I want to do, though, is I want to look at this and say, can I simplify this at all into something that maybe can combine with this? I can't really split this into anything. Technically, I could split it into square root of 3 times the square root of x. Maybe in certain situations that might help you. But here, I know that I can split this 27 at least into a 9 and a 3. Now, one of these is going to have to keep the x. 9 times 3 is 27, so the x has to be with one of these. But since I'm trying to create something that combines with this, I'm going to go ahead and leave the x with the 3. So now that I've split this into 2 pieces, I could put these together. Now, square root of 9 we should recognize is just 3. So if I was simplifying this, I split it into something that creates a perfect square. Square root of 9 is the whole number 3. The square root of 3x just comes down. And so I've simplified square root of 27x into 3 radical 3x. I still have this radical 3x being added to it. This is like a 1 radical 3x, it's just not written, plus 3 radical 3x. So I have 1 radical 3x and 3 radical 3x, so all together I have 4 radical 3x. Nothing like that will show up on your quiz this week. Again, I almost left it out because I don't feel like it's necessary right now. But these types of skills, this type of thinking, will help you drastically in your future math classes.